lesson 87 today. We're going to do some more with systems of equations, and these are the ones with the subscripted variables. So if you remember from lesson 79, go back to that maybe and look over it a little bit just to make sure that you know what we're talking about. But we're going to be doing that, and then a quick test for functions, which is actually a pretty easy one-line test. So here we go. So lesson 87, we're going to be doing some things that are a little bit more complicated than lesson 79. So when we solve systems of equations using the substitution method, sometimes it's necessary to rearrange one of the equations before the necessary substitution can be completed. So, or accomplished. So it just means that we have to figure out what we're doing and plugging it all in. I will tell you though that this main equation each time with all the letters, that's the one that you're trying to plug everything into. So you'll see that the most complicated one is the one you're trying to plug everything to. And get ready, buckle your seatbelts, because later on we're going to be doing story problems, and these are going to be the equations you're going to set up for this. So this is how this works. Okay, so what we're doing is we're taking these things over here and putting them into here. So what I like to do is I just go left to right. So I know RE is 200. So I'm just taking this equation here, plugging in what I can. And TE, we don't have anything for TE. So here's the question. I want to solve for TE and TW. I have this equation that has both of them in it, but I'm going to have to substitute one or the other. So what I like to do, and this is just kind of, like I said, there's about 4 or 5 different ways to solve many algebra problems. But what I many times like to do is take the first variable and leave it the way it is, and then substitute and mess with or rearrange or whatever you want to call it, the equation to work with the second time. So RW, we're given a number for it. So 250 goes in there. Okay, now TW, we don't have a number for it. We have an equation, but this is an equation where it's TE plus TW equals 9. I'm going to make it so that it's TW equals something. So to get this to go over there, I'm going to subtract T sub E from both sides. Obviously, those are not like terms. So my new equation is TW equals 9 minus T sub E. I'm going to take that chunk right here. And I keep saying the chunk because that just works that way. And I'm putting that into here for TW. That's what I'm going to do. I need parentheses because I have 2 terms. So don't forget that you're going to have to distribute. So now I've got TE and TE on both sides of the equation. I can solve for TE because I only have one variable. And that's my goal. So now I have 200 TE equals, what's 250 times 9? I can just come over here really quickly and figure that out. 2250 minus, and I'm distributing here, 250 T sub E. And then I'm going to combine like terms, or not combine like terms, I already have all of that. I'm going to move this over here so that I can combine the variable, adding to both sides. So I get 450 T sub E equals 2250. Now I just need to divide both sides by 450, and I find out that T sub E equals 5. And so I can figure that out if I want to by saying 45 times what is 225, or 450 times what is 2,250. 45 times 5, just to double check here. Yep. Okay, so if I added a 0 there, then that would give me that here. So T sub E is 5. Now, this is the easy part. This can go back into this equation here. 5 plus what equals 9. Subtract 5 from both sides. And we know that T sub W equals 4. And those are my 2 answers. So yes, it's going to take a little bit of time, but it's not super complicated. This is all pretty much the stuff you've been doing. It's just adding more letters to it. Okay, so let's tackle the next one. Example 2. We've got our R1, T1, R2, T2, and that equals 360. We know R1, R2, and we know this equation here, T1 plus T2 equals 10. So R1's going to go in here for 30. And I'm going to write down, I don't need a parenthesis right there. I can just keep that the way it is, T sub 1 plus R2, which is 40. And T sub 2, I don't want that. I want it to be T sub 1, something. So these are just basic algebraic equations. It's complicated, but you can do this. This is the one I'm looking at right here with that 360. I'm going to plug in this stuff here. So example 2 is very similar to example 1. R1 is 30. So I'm going to put 30, and then T1 I'm leaving. I'm going to make this T2 into a T1 somehow. And that's the substitution part that I'm looking at. So 40 goes in for R2. And then I'm going to go over to this equation here, and I'm going to put in something for T2 that has T1 in it. So I'm going to subtract T1 from both sides, T sub 1. And I get T sub 2 equals 10 minus T sub 1. Plug that chunk in for T sub 2. That's what I'm doing here. I'm putting 10 minus T sub 1, and that equals 360. So this is your most difficult part of the entire process. I'm going to distribute, solve for T sub 1. Everything else is just basic stuff that you've done before. Combine like terms, negative 10 T sub 1. Subtract 400 from both sides, and I get negative 10 T sub 1 equals negative 40. Divide both sides by negative 10, and T sub 1 equals 4. I'm not done because it asks for both T1 and T2. So I'm going to plug in T sub 1 over here, and I'm going to get 4 plus T sub 2 equals 10. Subtract 4 from both sides, and T sub 2 equals 6. Those are my answers. I can always check that. I can put them back into any of these, and they should come out to be a true statement. So make sure that you know that. You can always check your answers that way when you have equations. Alrighty, now the second part of this lesson has to do with the function line test. And like I told you, it's a really easy test to see if something's a function. So a function has only one value of y for each value of x. So we're going to put in things into them. So a function has only one value of y for every x. That's what makes it a function. Remember, we talked about this before quite a few different times with the machine. Given a graph, we can determine whether the graph could be that of a function by applying the vertical line test. If a vertical line intersects the graph in at most one point, only one point, then the graph represents the graph of a function. So it's saying any vertical line that I put on any of these graphs, if it doesn't intersect the graph at all, then I'm still at most one point, but it can only intersect at one point. So if I go here and I draw a vertical line, say this extends, we could say it comes way out there. I drew a vertical line there. Oh, that looks like it might be a function. That would be 1 point. But over here, if I draw a vertical line, I'm going to intersect at 2 points. So that makes it not a function. It doesn't pass the vertical line test. Example B does, because any of these vertical lines that I draw on the graph will only intersect at 1 point. And so that makes this a function. Letter C, vertical lines intersect at only 1 point? No, they intersect at 2 points, and so this is not a function. And then this final one looks a lot like this, but just turned up, facing up, and so Here we've got our vertical line test. Yes, it's a function. All 4 of these examples made it so that we didn't have to do the example 4 down there, so you can just cross that out. So there's your vertical line test. Actually, it's a easy test just to make sure that it's a function or not a function. Alrighty, I'm going to go over a few problems here in your assignment because some of you are having difficulties with some of these, and I want to make sure that you're catching some things that you might need to know. These are what we just went over, so you've got your basic problems there. This one is your long division, and this is something that you need to make sure that you're understanding because we do not have an x term. We just have a x cubed and an x squared. There's no x term. So what I do is I keep that place. So I'm going to put x cubed minus 2x squared, and I keep that place by putting 0x plus 0x and then plus 4. And that makes it so that when I'm subtracting and adding, I've got a like term to come up with. And so I want to show you this so that you can see how that works. This is super important. You don't have to put that there, but you just have to remember that when you come and bring the x term down, it cannot combine with the 4 because it's not a like term. So x goes into x cubed, x squared times x is x cubed. X squared times 2 is 2x squared. Now I'm going to subtract, and that becomes addition. Negative 2 plus negative 2 is negative 4x squared. Now I'm going to say x times what gives me negative 4x squared, and that would be negative 4x. Negative 4x times x is negative 4x squared. Remember, that's how you know you did it right when they multiply and become the exact same thing. Negative 4x times 2 is negative 8x. Now see, when I bring this 0x down, it's a lot easier to add those like terms. If the 4 were over here, I might be tempted to put 12x, which would not be correct because that's not an x. Now I'm going to subtract by changing the signs. 0 plus 8 is 8x. Now I bring down my 4. So make sure that when you're doing these problems that you have an idea of where these places go. If you need to put a place value in there, please do that. And that's the best way to do it, is to put plus 0x. I've had it before where I've had, say, something like this, where it's x cubed minus 2, and then I have a plus 0x squared plus 0x, and then your minus 2. So you're welcome to put those in there because when you do this, you won't have to try to figure out where your like terms are. Alrighty. Down here, oh, I already have the equations for you, but I want you to see how these equations work. We're talking about 2 different equations. One is the value of the coins, and the other one is the number of the coins. So the number of coins added together is 500. That's why we have the number of nickels plus the number of dimes is equal to 500. Now remember, $30 is 3,000 cents. And we're going to change everything to cents when we do this second equation. So 5 cents times the number of nickels plus 10 cents times the number of dimes is equal to 3,000 cents. Then you're going to use substitution or elimination to solve those equations. So make sure that you're getting 2 different equations there. The number of coins and then the value of the coins. Super important. Alrighty. And then right here, there's a little thing that I'm noticing in some of your homework assignments, that this x squared here, when you put something in that's a binomial, you're going to need to FOIL that. So what you are going to have is this x squared becomes, I'm going to put a bracket there because it's y plus 1 times y plus 1. And then the negative is of all of that. So do your foiling first, then change all of the signs with that negative. So don't let that trip you up. Alrighty, you got this. This is good assignment, only 13 problems. As always, let me know if you have any questions. See you later.